The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. And the topic of today's session is addressing aggressive infrastructural NFRs using Virtualized Ecosystem. Our guest speaker today is Narendra Negi. He is a Senior Specialist Infrastructure, SI Practice at Sapient Nitro Consulting Private Limited. Currently working as a Senior Infrastructure Architect role in Sapient Consulting Private Limited, having more than a decade of experience in middleware technology, virtualization, and cloud space. He is also a part of SI practice within Sapient and responsible for building capabilities around middleware and cloud solutions. Having deep understanding and knowledge on middleware technologies used across content and commerce business. Primarily responsible for defining and designing the end-to-end infrastructure landscape solution for all content and commerce-based business. He is an engineer graduate by profession. He started his career as a system administrator, moved into the world of middleware and cloud technologies. His current interest is focused on leveraging cloud space and its underlying technologies for all type of business running on enterprise middleware solutions. So without further delay, I introduce you all to our guest speaker. Over to you, Narendra.
Thanks, Adna. I hope this is visible to you guys. Okay, welcome all and thanks for taking out time to attend this webinar. In today's session, I'm going to talk around non-functional requirements, its importance, and how the business ask on these NFRs has been changed over the past decade. I will also cover how changing infrastructure landscape by moving from traditional infrastructure to virtualization ecosystem and later on to cloud helps in addressing these aggressive non-functional requirements. As part of the agenda, I'm going to cover the session in twofold. One is the importance of the non-functional requirement, where I will talk about the NFRs, and the other session is more around the virtualization. Specifically, I will deep dive into some key features on the server and the storage virtualizations, and then I will try to correlate how the critical non-functional requirement can be served using the virtualized ecosystem and the enablers for the today's cloud space like IaaS, PaaS, and SaaS. And last few minutes is more around the question and answer. I will try to respond to the open queries. Okay, so what is NFR? Before we actually define the NFRs or we deep dive into the non-functional requirement, I think we'll take a step back and try to understand the requirement. So on a broader level, a requirement has been categorized into two buckets. One is the functional requirement, the other is the non-functional requirement. Most of us who had been involved in client workshop during the project discovery phase in gathering the client requirement, I believe that he or she is well versed with these terms. But there's no harm in actually refreshing these things again and again. Functional requirement is what that describe the behavior in terms of the functions or services for the systems that has to be designed to support user goal, tasks, or activities. Whereas in the non-functional requirement, there's no standard definitions to it. Someone define it or call it the requirement to define how software will do it. Someone defines it as a constraint to the services or functions offered by the systems, or you can call it as attribute or quality that the product must have. Requirement that describe not what the software will do, but how the software will do it. For example, requirement around the performance, requirement around the external interfaces, design constraints, and other are generally called as non-functional requirement. So in a single liner, I would say that specification of how well a software system must function is nothing but a non-functional requirement. So in a functional requirements, the requirements are totally different from the non-functional requirement, because there are usually much more difficulties in designing and testing of the non-functional requirements. Getting a design to meet the non-functional requirement often take a large portion of the schedule and is filled with a lot of problems and integrity, where the functional requirements tends to be more straightforward. For example, setting a database to store or retrieve a transaction is pretty straightforward, and this is nothing but a functional requirement. But let's say if a business has a requirement of getting a high performance out of a distributed infrastructure with high load, requires a lot more of thought, designing, and way of validating and testing this particular requirement. So there's a huge difference between a functional and non-functional requirement that everyone has to understand that. Classifying the requirements. Though there are few IEEE standard models that listed non-functional requirements to be included in a software requirement document, but I would say that the first model is one of the unified proposed process through which you can classify all these requirements. First is nothing but the acronyms of a functional, usability, reliability, performance, and the supportability. The plus model also provides the additional requirements under the general level of non-functional requirement. An example is like, say, the implementation requirement, where the constants are more related to the coding or the construction of the system. For example, business require a standard platform or implementation language like C, Java, or Visual Basic, something like that. Interface requirement is a requirement to interact with the external party, how the system has to call or do a third-party calls. Let's say it could be probably over the HTTPS using SOAP call or something like that. In terms of the design requirement, it's primarily constraint related to the design of the systems. Example could be a relational database is required, or let's say single sign-on function is required. So these are nothing but the constraint related to the design. A physical requirement is nothing but more around the constraint imposes on the hardware used to house the infrastructure. For example, the model and specification of hardware, whether it should be deployed on RISC-based system, CIFS-based system, or in the public cloud, private cloud, or the hybrid cloud. So these are the constraints that generally been put in while we actually talk about these requirements. Coming to the first model again, when we say the functional, so these are the high-level bucket which can be subcategorized into the other non-functional requirement. For example, the functional is where you can talk about other non-functional requirements like capability, like reusability, security, compatibility, interoperability. So these can be subcategorized into or can be put into a single bucket called functional requirement. All functional requirements usually represent main product features. For example, processing or the order process requirement that the client has or business had. This can also be architecturally significant in terms of auditing, licensing, let's say online help, chatting system, reporting, security, and so on and so forth. When it comes to the usability, it's more around how the system can be made usable and discover functionalities or the non-functional requirement like human factor, consistency, documentation, reporting, responsiveness. Coming to the reliability, they can again subcategorize into non-functional requirement, which is more related to the reliability of the system, like availability, failure, recoverability, stability, accuracy. Performance is again more around how the system is going to perform, and the non-functional requirement which can be subcategorized into this performance big header could be like the speed of your hardware, the efficiency that you really want to achieve, resource consumption in terms of the CPU, memory, cache, etc., throughput of your system that you're looking for, capacity, scalability. All these non-functional requirements generally come into the performance bucket. Supportability is more around maintaining or providing a support to the systems, and the NFRs like serviceability, sustainability, maintainability, adaptability, modularity, all such type of requirements generally fall into the big bucket, like big bucket called supportability. When it comes to the example, let's say if there's an example or if there's a requirement of a product that should support multilingual, that is nothing but a supportability requirement. If the business requirement is more around the persistence of your, the persistence should be handled by a database, is again is a design requirement. Database is specifically should be 11G, Oracle 11G. This is more like an implementation requirement. An online chat system is required, is nothing but a functional requirement. Let's say a presentation layer would be written in Java, or let's say in Visual Basic. That is more like an implementation requirement. If the requirement is more around that system should be available or should support 99.99%, is again is more like an availability requirement. So these are the high level categorization of your requirement, be it functional or be it non-functional. So managing NFRs, everyone who designed the solution should understand the importance of NFRs. So overlooking the NFRs is the first indication which I believe that can bring the systems into a failure state. So these NFR actually helps in defining and designing the solutions, and for any infrastructure architect, it helps in transitioning or translating the physical and the network topology of the system. So in order to have the success of the system, it is very, very vital to ensure that you close all relevant non-functional requirements with business stakeholders on time, so that you can actually start building up your solution with the great visibility and considering success criteria. There are key points. What I would say is that has to be taken into consideration while managing NFRs during requirement phase. Make sure that you come up with a list of questionnaire for gathering all the NFRs. Also ensure that every non-functional requirements have more than one questions, so that you can have a complete understanding of each NFR from the business. Capture the response. I would say that when you actually talking to a business, most of the time the business stakeholders are not so technical, so it's always good that when you actually talk around the non-functional requirement, you give the clear visibilities around the impact of answering questions or around that particular non-functional requirement, so that you can get a better response from the stakeholders. Make sure that you actually capture all the responses on a sheet or on a document, so that that same can be referred while designing the solution. Always ensure that while you're talking to a business, you always make sure that there should be some priority or weightage that has been given to the NFRs. So the prioritization can be done either in high, low, medium way, or it can be like, let's say you can provide a weightage like good to have, must to have, something like that. Let's say, just to make it simple, let's take an example here. Let's say we have an NFR around the availability, and then if you have to come up with the questionnaires for the availabilities, then it should be regarding system uptime, and which can be measurable in terms of your mean time before failure, MTBF, and MTTR, mean time to repair. In terms of the impact that you need to mention in your document is that if, let's say, the higher the availability, better is the user experience, and I think the long-term success of the product. So this will give the clear visibility to the stakeholders in terms of understanding that NFR. In terms of the response that you have to capture, that you clearly need to make it measurable in terms of saying that, okay, the client is looking for MTBF of 90 days, MTTR of, let's say, 4 hours, so that's something which can be measurable or can be measured while you're actually doing the operational acceptance test, or while you're actually doing a sign-up for an SLA while you are actually going into the production mode. In terms of the priority, you know that this is more around the uptime. This should be very, very high prioritized. So the priority should be very, very high. So you can basically come up with an Excel sheet, making sure that every categorization, every NFR categorization has been done properly in that fashion. So over the period of time, I've noticed that there are very, very few common pitfalls that everyone can avoid while getting the non-functional requirements. For example, requirements are too general. Let's say an analyst reaching out to stakeholder and querying the questions like, do you need multilingual support? Do you need security in place? What availability are you looking for? So I think in such cases, stakeholders generally say yes, no, or in terms of the availability, they say, okay, I need 100% to supporting 24/7. So I think they are valid non-functional requirement queries, but I think they are not actually getting into the deep dive of what you really want to achieve from the business. So these requirements are very, very generic in nature. So make sure that when you reach out to stakeholder, be as specific as possible, and also while talking to them, it is always good to have that you ensure stakeholder understanding the cost impact of the ask they are looking for, so that they can correlate to it. For example, an availability of 100% is something which can cost a huge in deploying an infrastructure as compared to an availability of 99.9% or 99.99%. Requirements are not measurable. I think this is one of the other common things which we generally not captured. So in such cases, we always need to ensure that requirements are unambiguous and should be as measurable as possible. For example, when it comes to the availability uptime requirement, it should be, let's say, 99.9%, 99.99%, or when it comes to the performance requirement, means what is the transaction per second they are looking for each individual pages, what is the content traffic that the system should handle. So all these things should be measurable so that it actually don't bring any ambiguity while you actually implement the solutions. Lack of time is one of the factors that I've seen in over the most of the business stakeholders. That is personally my experience seeing that. So if you feel that there's something which has not been captured, what you need to ensure that you constantly remind stakeholder around the importance of these requirements, and make sure that you get the responses captured at the earliest stage as possible. Lack of ownership. This is one of the other pitfalls So it is also noticed that a lot of times system or the business analyst lack the ownership of gathering these requirements, be it because of the low knowledge around the non-functional requirement or because of some other reasons. But we need to ensure that they actively create, tailor, and understand the questionnaires before reaching out to business stakeholders so that they actually capture the responses in proper way and proper fashion. Talking to a wrong people. So it is must that you get the responses from right set of stakeholders. So one of the important point to identify stakeholder responsible for answering such questions. So you need to make sure that against every NFR there is a proper stakeholder name so that you can reach out to the specific person or the stakeholder. The NFR question is technical. So in such cases, what you have to do is that you actually come up with the business impact so that the business stakeholder can understand how this NFR is going to impact the business in the long run. All requirements are equal. As I said, that it's always good that you prioritize and give some weightage to the requirements so that you can prioritize or you can filter out what is not required or what is least required when you actually go into the implementation, or even during the requirement phase. You can prioritize what has to be taken into first phase and what has to be taken into second phase, something like that. So this is a tabular format that is depicting change in NFR ask in last decade, right? So if you look at the first column, it primarily talks around the key critical infrastructure non-functional requirement and how these requirements were in a few years back and where these requirements stand as of now. For example, availability. A decade ago, system with 99.9% were considered to be very high available. But today, business is looking for 4 times 9 or 5 times 9 solution, which means that on a year, you cannot have a downtime of more than 52 minutes. So you can compare how aggressive the ask has been changed over a decade now. On terms of the disaster recovery, DR sites used to happen very rare a decade ago. If in case they exist, they are more into, let's say, active-passive mode. But today, business understand the impact of not having any sort of DR in place. So if you go into the requirement phase, then you'll see that every business is now actually looking for DR to be in place, either in active mode or in active-passive mode. The recoverability, I think it again gets categorized two parts. One is the recovery time object, which is nothing but how quickly your system can be recovered once you invoke a disaster. And recovery point object is nothing but the amount of data the business can sustain, the amount of data loss that business can sustain. So a few years back, RTO of 4 hours and RPO of 24 hours is something which generally business looked for. But today, RTO and RPO, it's instant RTO and RPO that is the business is looking for. So they really don't want to lose any of the data. They really want to say that, okay, let's say if we invoke a DR, the DR should be get activated in no time post invocations, right? Backup and restoration. So earlier, taking 1 terabyte of data used to take 24 hours. Now the change is that it has to get done in few minutes or few hours. Retaining a data for longer period of time is always a challenge in past as well. So let's say if you have to retain data for more than 1 year, you really need to have a huge space to actually put that data in place. But this has been changed with the latest technology in place, where you can basically reduce the overall space requirement by at least 10 to 20 times. We'll talk about that in the later sessions, but this just given just how the things are getting changed over the last decade. In terms of the scalability, a traditional infrastructure generally takes 4 to 6 weeks, but now with the cloud in picture, virtualization in picture, everyone is looking for auto-scaling at the max. The scalability has to be done in few minutes time. Manageability, earlier we used to have storage admin, we used to have network admin, we used to have server admin, operating system admin. but I think with things getting consolidated and with a single console, you can manage your network, you can manage your storage, you can manage your servers. I think the overall operational cost has reduced drastically. Okay, so till now we've been talking about the non-functional requirement. We're giving the gist of how the non-functional requirement look like, what are the critical infrastructure non-functional requirements are. Now we've been talking about the virtualization, how the virtualization technologies or the features that actually helps us in meeting those aggressive non-functional requirements. So in subsequent slides, I'll try to cover some key virtualization features that actually helps in meeting some of the critical infrastructure NFRs that have been changed over the period of time. So how the virtualization has moved or is moving ahead. So I have put some of the reports that have been published by key research and advisory firms around the growth of virtualizations. For example, a report from Gartner says that today's more than 90% of the enterprise have a virtualized program, the project running, whereas only 40% of servers workload are into a virtual machines. The other Gartner report says that the x86 based server virtualizations will double from 40% in 2011 to 80% in 2016. So that basically give us a clear view around the shift of the hardware architecture. So earlier we used to work on most of the work, the enterprise things generally used to work on the risk-based system. For example, we used to have IBM AX, Citrix, Sun Solaris, but now I think the shift is more into the virtualization, which gets supported over the x86 systems. Even the desktop virtualization is again is evolving one. It is expected that by 2015 or end of 2014 there will be around 50 million desktop virtual desktop in market. So 60% of the new servers workload is actually going to be in virtualized environment. So a report from Forrester says that by 2020 there will be almost $241 billion that will be spent on cloud computing. So that's the high level gist that give you a clear picture of where the virtualization is moving. In terms of how the consolidation has happened over the past few years, the working of your cloud from the virtualizations is that what this particular slide is depicting about. So if you look at this slide, I think it says that at the earlier stage everything was physical, right? The phase one is where virtualization made its way into the mainstream data center with a strong cost reduction value proposition using server consolidations. So, so with the help of server consolidation, that actually helps the overall capital cost reduction by 60% in some of the cases. So phase one is the phase or the era that was more around the server consolidation. Phase two is the journey of the business production phase, and at this phase the value proposition actually shifts from the consolidations to the virtualizations in order to achieve better quality of services in terms of performance, reliability, or the business continuity. So at this point the organizations take cost saving from consolidations for granted and start focusing to move for faster provisioning, better capacity management, reliability, and the automation for the business application. The final phase is where we actually we are right now, or the industry right now, is the phase we call it as IT as a services or cloud computing. So customers in this phase have more than 50% of their data center virtualized, and it's now becoming a norm to it, right? So, and hence these companies have automated more processes, deployed new services faster than ever before, and are getting extremely high level of performance utilization. So this particular phase is more about the agility, scalability, and performance. Okay. Coming to the server virtualization, under server virtualization, I will try to cover virtualization features that primarily help in achieving non-functional requirements like availability, scalability, maintainability, fault tolerance, and sort of active DR. So before we actually deep dive into these virtualization features, I would just want to rephrase what the virtualization is and what are the key building blocks for the server virtualization. So virtualization is nothing but a proven technology that rapidly transforms the IT landscape and fundamentally change the way we actually compute, such as the operating system, server, network, storage. So in upcoming slide, for my reference, I will be talking around the VMware as a virtualization feature, as this is one of the top virtualized products used across industry. Other virtualization products also do have more or less same features in line to what VMware do, but I've just taken VMware as a reference for my subsequent slide, specifically in the server virtualization. Okay, coming to first non-key mission critical non-functional requirement is the high availability. How we can achieve high availability using the virtual clusters. Let's say your application do not support clustering, or you do not want to have the application level clustering features because of, let's say, licensing cost or some constraints to it, but you are still looking for the HA solution, then virtualization HA is the right solution for such ask. So if you look at this figure, it depicts three physical servers, server 1, server 2, and server 3, and all these servers are part of a single cluster with a single resource pool configured into it, and all these again all these servers or ESX server are part of the same resource pool. So let's say if any of the hardware goes down or the physical host goes down, in such cases, so all the associated VM which are part of this particular ESX source will automatically get migrated to the other resources or to the other available physical hosts which are part of the same clusters. So that's primarily talk around the VMware high availability. So this primarily happened in very, very quick time. So it just needs a restart of the server. Server will automatically get restarted to the OK node. VMware has again got another features which is part of the VMware HA, which is nothing but the fault tolerance. However, high availability is not synonymous with the fault tolerance, so there are meaningful differences between the two terms. It's essential that you understand the client uptime and data recovery need to determine what you need here. So HA is nothing but a base level protection where your virtual machine will get restarted into the other host when the one of the physical node goes down. Whereas fault tolerance provide a high level of availability, so there will be a seamless migration of the virtual machine into the other host. So that is where I said that it's very, very key to understand what the business is looking for, because high availability is the HA is one part of the high availability package, and the fault tolerance is another part of the high availability package. This high availability solution is generally best suitable for the application which really do not support out-of-the-box HA solution, for example, Jira. I said that you can probably want to leverage the clustering for non-production environment where single host is actually to host cluster is actually hosting multiple database servers, and that can give you better return of investment than hosting a physical database servers for your non-production environments. The other key non-functional requirement that I'm going to cover is maintainability. So VMware has a very good feature called as DRS and VMotion, through which we can basically maintain our systems or can do the regular maintenance without any outages on the systems. So in traditional infrastructure, there was always been a challenge for IT in terms of minimizing the overall downtime during any maintenance activities. So with VMotion feature in place, no downtime is required during maintenance activity. A VM can seamlessly move from one server to other servers using VMotion features in a cluster, and hence servers can be taken out for maintenance. DRS is nothing but a distributed resource scheduling, so that determines the best possible distribution of virtual machines among different physical servers and automatically migrate virtual machines to the most appropriate physical servers in the case there is a physical resource crunch on the servers. For example, if you look at this figure where the server 2, where the CPU is actually reaching out to 100%, so DRS will actually invoke automatically as per the threshold that has been mentioned, and some of the virtual machine will automatically get migrated to other of the hardware or the ASIC server, which is being less utilized. DRS along with the distributed power management can also help in bringing up the efficiency of the systems. So during maintenance, what you can do is that, let's say if you really want to upgrade your hardware, what you can do is that you can basically migrate all the virtual machines from one of the hardware which you really want to repair or which you really want to upgrade to rest of the hardware which are part of the clusters. DRS purely work on the VMotion. VMotion is nothing but a live migration of virtual machine from one host to other. So VMotion is the underlying technology that basically helps or enable the DRS to work properly. Scalability. So it has been a pain to create a new virtual machine with the right software installed and configured properly. In fact, we used to leverage tool like Kickstart to automatically install the operating system, and then over to it we generally used to install the other software as and when needed. But configuring such environment is not trivial, and it takes long time from start to finish. And as the virtualization is moving ahead, a lot of virtual machines are being provisioned, decommissioned on day-to-day basis. So going with the older approach of doing the installation one by one is a gone method. So that is where with virtualization, a lot of virtual machines are being provisioned and decommissioned. The other side of it is that the virtualization brings a feature called template cloning, which offers an easy solution in terms of creating a virtual machines. You can pick and configure every piece of software that you need into the template and clone it to a new instance whenever needed. So it's not only the easier way to do it, but it's very, very fast. Let's say if you really want to set up an environment with same sort of application deployed to it, then this is really a very, very fast method to do so. In terms of the scalability, a single host can deploy as good as 256 virtual machines over to it. Each virtual machines can be scaled to 64 virtual CPUs, and the memory, physical memory, can be that a single virtual machine can support is up to 1 terabyte. So you can probably horizontally scale your virtual machine up to 64 virtual CPU and 1 terabyte of RAM into a single physical ESX host. So that is how much you can basically scale your virtual machine and hence your infrastructure. Zero time multi-site cluster, stage cluster. It's more like an active cluster. I think traditionally data center architectures had hard distinction between high availability and disaster recovery. So high availability was considered an automated failover solution within single data center, whereas DR was a manual process for recovering site from the replicated data. But recently, data center architects have begun to look a solution that sits between these original directions or original distinctions. So these solutions include the architecture such as stage cluster, or someone calls it multi-site cluster or metro cluster. So these primarily offers the ability to balance workload between two data centers with no disruptive workloads, enabling the migration of the services or the virtual machines across both the data centers without any outages. But there are certain limitations to it that if you really want to set up a metro cluster or active-active cluster, leveraging both the data centers purely in active-active mode, you need to ensure that both the data centers should be in range of 100 kilometers. Latency should not be beyond 5 milliseconds. If you are leveraging the fault tolerance, then fault tolerance has a limitation that the latency should not be 1 millisecond. So make sure that if you're leveraging a fault tolerance and if you are going with the active-active multi-site clustering architecture, then latency should not go beyond 1 millisecond. In the multi-site cluster, both the storage are always in read-write mode. They are actually doing the block level synchronous replication across both the storage. Okay, coming to the storage virtualization, so just like server virtualization, we will quickly talk around how storage virtualization ecosystems helps in addressing critical non-functional requirements like data protection, recoverability, and data retention. So what is storage virtualization, and what are the benefits that we generally get from the storage virtualization? So abstraction or isolating of physical storage functionality from application services is nothing but storage virtualization. Or another word, or in simpler word, it's a pooling of physical storage from multiple network storage devices into a single storage devices that is managed from a centralized console. So a storage virtualization is not a new, I think not a new feature. If I recall it, I think some sort of storage virtualization has been running since mainframe era. Like your LVM and RAID are again nothing but some sort of storage virtualization. So in terms of the benefit that we generally get out from the storage virtualization, so with single logical unit, it actually isolated the storage services from the applications, which essentially means that application will never come to know from which storage data is being served. It simplified the enterprise data management through a single console, and hence it minimized the overhead for the storage admin. Earlier, any old storage that has to be phased out or let's say needs to be upgraded would always require a lot of planning, downtime, and operational cost to migrate the data from one storage to a new storage. But with storage virtualization, data can be migrated in non-disruptive manner with a very, very less time. We can now club old storage and the new storage and using storage tiering features to actually allocate application resources to appropriate tier. Example, mission critical application can be deployed, let's say on tier 1 using SSD drive. Less critical application can be deployed in tier 2 using SAS drive. Application which are non-critical are for the development mode, or if data has to be backed up, I think these sort of data can be pushed into the tier 3 or the SATA-based storage systems. So with features like auto tiering, with single management console, and overall consolidation of storage, primarily helps in reducing the total cost of ownership using the storage virtualization. The other benefit that we get out of the storage virtualization is that essentially all storage block level applications are vendor agnostic. That's how the current storage vendor model is. But with the help of storage virtualization, it actually supports the heterogeneous applications. Hence, data centers can be replicated across 2 storage vendors. So that is really one of the great features that actually come up with the storage virtualization. Data protection, the key feature here is that I think before we actually deep dive into the data protection, we'll try to understand what the data protection is. It's nothing but the ability of the system to protect the data in case of the system failures. Storage snapshot is very good feature when it comes to instant backup and the restorations requirement. So it's nothing but a point-in-time backup copy of storage. So these features help in storage data replication across multiple data centers where only block level changes get replicated, thus reduces the overall bandwidth required for the application. The only downside of the with the snapshot is that if you really want to revert back to old snapshot, so all changes will be reverted that had been taken between last snapshot and the current state, which means that you cannot restore file or folder level backup in this case. So essentially this storage snapshot is not a pure standalone backup solution. Rather, I would say that it's more like a catalyst for a system to provide you data protection. So there are multiple ways of creating a snapshot. Example, you can go with copy on write. So within a storage, there's generally when you configure storage, you actually reserve some sort of snapshot area into the storage. When you enable a feature called copy on write, any changes in the existing block which is first copied into the snapshot area before the block get overwritten or get modified. The other way of doing the snapshot is more around the redirect on write, where the block is redirected directly to snapshot area so that the latest copy or latest changes on the blocks are written to the snapshot area rather than the actual area. The other way of doing it, like split mirror through the log file as well. But what I will say is that I'll quickly try to cover write and copy method. How does it work? So
Narendra, are you able to hear me? Your voice is not audible. Can you please check? Hello? Narendra, are you able to hear me? Narendra, you are not audible to the audience. Can you please check your audio settings? Narendra, you are not audible to the audience. Please respond. Narendra is trying to reconnect with us. Please have patience. He would again resume the presentation soon. Hello, Narendra. Are you able to hear me?
Hello. I can. Am I not audible to you guys? I think I got disconnected somehow. I don't know how, but.
Yes, you did. You did. Please continue with the session.
Can you tell me where I was? Was it really help me to understand so that I can connect from that session itself?
Yes. So you can start with the fresh slide because the second point you missed out. So you can start fresh with this slide.
Okay, cool. Thank you. Sorry guys, I was somehow disconnected. Anyways, going to the session again. Just refresh what I've been speaking out. I'll just quickly go through the event sequence, how the snapshot mechanism works. As I said that when the storage is configured, storage admin generally reserve some sort of data and make it as a snapshot reserve area. It's generally between 15 to 20% of your total data space of your storage. This particular area is where the change in data or the delta data has been pushed when you keep the snapshot over the period of time. When the snapshot is created, it primarily takes a logical copy of the data. Once it actually froze your application for a very short period of time. Let's say if a write request comes from a system and it has to modify the existing block, then in that case, the first step is to the existing data from the same block is first written to the snapshot area, and then the data gets modified into the actual data space. A read into the logical copy is redirected to original copy. So if in case the data is not been modified, all the read requests will actually coming from your actual data space. If in case a read request which is coming for the modified data, then in that case the request will actually go into your snapshot area and fetch that data. And that's how the snapshot mechanism works. Coming to the recoverability block level application, I think the block level application is what is the underlying technology that's being used to replicate data across the site. So when it comes to recoverability or DR, nowadays data replication across site is mandated operation specifically for the case where that has to be replicated is very, very huge. Few years back, data replication was purely dependent on the application layer to keep the data synced across two data center. Example, syncing the static content using, let's say, rsync or the robocopy daemon utility, syncing or replicating your ADLDAP data is through the ADLDAP sync. Same is the case for the databases as well. But now we can leverage storage application tool to replicate data across two data centers. Replication could be on a broader level. The replication categorized into the host base and the storage base. So I'm just focusing on the block level replication. I'm not at all talking about the high level replication. I'm not considering the application based replication, which is more like a file system based application. So the host base and the storage base is purely a block level application. So host based application is where you have to install agent on individual servers to make sure that the agent work or do that replication for you. So in that case, you can have one-to-one replication, or you can have many-to-one replication. Whereas in block level or the storage based application, basically the replication is get done at the storage layer or the storage array layer. So here, rather than the file system get replicated, basically the storage LUN or the volume that actually gets migrated. So any virtual machine that actually is being deployed or being cut out from that particular LUN or volume will automatically get migrated as part of that particular LUN replication. So replication can again be categorized into two parts based on whether you need a synchronous or asynchronous. We'll talk around both things one by one. First, we'll see how the host-based application and the storage-based applications are different from each other. So if you go with the host-based application, in terms of the benefit that we'll get is that host-based application is not the storage agnostic. So if you, let's say you have two data centers using one data center using NetApp storage, another using EMC storage, then there will be a huge challenge in terms of getting data getting replicated at the block level. So host-based application is the best way through which you can do it in such scenario. You can relate both synchronous and asynchronous. You can schedule both ways. Data, in this case, data can be reside local to the storage or local to the server, or could be on storage. It doesn't matter because the agents are responsible which are lying in the file systems to replicate the data. So it generally do not impact that with the storage or the hardware update because it's an agent-based mechanism. In storage-based application, let's say you have the same single vendor across both the sites, I think this is the best way to do the application. So these are the vendor agnostic, so vendor dependent, so you can go using this route to actually replicate your data. There will be no performance burden because they are not dependent on the host. It is done at the storage level, so the performance burden is generally done at the storage end rather than the server or the host end. It does not depend upon the operating system or the file system, as all the data that gets replicated is the block data. You really don't have to configure any agents on the server, so there is no overhead of installing any agent across tons of servers in case it has to deploy across enterprise solutions. The downside of it is that in host-based application, since it's agent-based, has to deploy on the host side, it actually consumes a lot of compute power into the host. It depends on the operating system. You really need to make sure that the correct agent is installed on the type of operating system you are running for the application. And it's generally not suitable, like I said, that for the enterprise class where let's say 100 of servers has to be replicated across the two sites. In case of the storage-based application, it's vendor locked in. You cannot leverage this piece of application across two different storage vendors. The cost is really, really high. The licensing cost to purchase the replication is additional, additional cost over and above for that we procure for the storage hardware. So all the data that you really want to replicate has to be reside on the storage array. You cannot have any data that is lying into the local servers. Best fit. So a host-based application it does fit in the environment which are using multi-vendor storage, where you really want to ensure that in some cases you want to do a sync replication, in some cases you really want to do async replication, and if let's say if your use cases is to get a single data get replicated to the multiple target or the vice versa, then host-based application is the best way to do it. Storage-based application, let's say you are a single vendor partner, or you really don't want to invest to learn multiple technologies and you are preferred for single vendors, and I think this is the best technology that you can go for. It basically replicates one-to-one, so you cannot have replication from one server to multiple storage, so one storage to multiple storage. It can be cyclic, but it cannot be one to multiple. In terms of synchronous and asynchronous, when to go for synchronous application, when to go for asynchronous application, I think when it comes to the distance, as I said, that latency is the major factor in deciding whether you really want to go for synchronous or asynchronous. Up to 100 miles, latency less than 5 milliseconds is something you can go for synchronous. Asynchronous, if you really want to have the global application done, then you can go for the asynchronous across 2 regions, something like that. With synchronous application, you really need to have a huge bandwidth, because the time to take to commit the data to the other data storage will basically can hit your performance. So you need to make sure that you have less latency and more bandwidth to go with the synchronous application. But in asynchronous application, there is no hard boundaries into it. It can vary from with the change in the rate of data. In terms of the recovery point, synchronous is always replica of your master or your primary data center, where asynchronous is always some downtime to it. Best fit, if let's say you have a high bandwidth to low latency, application performance is not primary concern, where you really need to have a requirement of RPO of 0, then you can go with asynchronous. Whereas asynchronous, where you have to have 2 data centers across 2 different regions, let's say one in APAC, another in northern region or the European region, then you can probably go with this particular application type. Coming to the way the data has been grown over the past few years, we'll talk about key virtualized feature called data deduplication, which primarily helps in duplicating data and reducing the overall space required for the system.
Narendra, I'm really sorry to interrupt.
Yeah.
Yes, we are way past our scheduled time, so if you would like to just wind up the session for today, please do it now.
Okay. So what I would say is, how much time do we have right now? Another 5 minutes?
You can have few minutes to finish up the session, and then maybe take one question. Rest of the question you can take offline.
Okay, cool. So what I'm saying is that data deduplication is a process through which you can basically remove out any redundant data at the storage and or at the server layer. So this particular feature generally helps you in bringing out or reducing the overall space required into the server or the storage end. You can use deduplication at the storage. You can use deduplication for your archiving data, for your backup on the tape side. You can use the deduplication feature for your disk-to-disk backup. You can use it over the WAN accelerator while you actually transmitting your data from your source to a target DR site. This is the last slide, which will give you gist based on the RTO and RPO. What is the best mechanism that you can opt for? For example, let's say your RPO is very, very aggressive, then it clearly says that you can probably go with the active-active clustering. And same can be achieved using synchronized replication, but the cost to have the active clustering is very, very high as compared to the synchronous clustering. or synchronous replication. In terms of the recovery time objective, as I said that because you have the active data center, active clustering gives you very high aggressive RTOs, whereas the other mechanism like synchronous replication, asynchronous replication, and the snapshot assisted application, you can achieve the better RTOs as compared to your paid backup and the offline application. So it totally depends what the business ask is. If they are really looking for, let's say, just the 0 RTO and 0 RPO, then active clustering is the best way to do it. And if they have, let's say, 0 RPO but 4 hours of RTO, something like that, that they can go with the synchronous application. So these are some things which have been taken as reference. I think I'm almost done. Thank you. So I'll just quickly go into the questions and see if someone has any questions. Okay, there is one question from Mukesh Kumar where the question is, what is the benefit of template apart from being fast over using configuration management tool like Chef Extra? I think this is very valid and nice question, Mukesh. So both has got the benefit to it. At the end of the day, if let's say there's a lot of customization that has to be required, I think the configuration management tool, which could be your Chef, Puppet, Ansible, you can leverage that thing. But if let's say if you know that there's a static deployment that has to be done across, let's say, 100 virtual machine, I think templatization is the best way to do it. But for any customization or change in the configuration that is very rapid, then I think configuration management is the best tool to go with. I hope that answers your question.
So we have lots of questions coming in, but I would request you to sum up the session for today as we are running out of time. So if you would like to have say some closing lines before we close the session, please do it now.
Okay, so what I would say is that my recommendation here is to understand the client business requirement very clearly, ensure that you list down all NFR questionnaire that helps in system requirement gathering, and avoid common pitfalls. So once you have all the requirement handy, it is always easy to choose the right set of solutions or technologies, be it at the virtualization or at the cloud or at the doing it in the traditional way.
I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Narendra, for taking the time out and having us. I hope you have a great evening ahead.
Thank you.
Thank you. Bye-bye.